Okay, so there is a lot that we are going to do. So welcome to this. This is the Solidity Interacting with Solidity Smart Contracts workshop. This is mainly here so that we can prepare all the BNB developers to make their first Greenfield DApp, and that's the goal. We want to make sure that we can interact with data storage using permissions, using smart contracts. This SDK for interacting with smart contracts right now at this date, it's April 15th, is not available right now, but it will be. And so I figured that I worked this week on making a Solidity kind of guideline on how to get comfortable with writing smart contracts, especially with interoperating with other smart contracts, because you're going to have to use permissions and other sets of APIs to do this with Greenfield. And if you're not familiar with what Greenfield is, it's a data storage network, and it's not EVM compatible. However, you can write smart contracts that interact with the data that's on Greenfield, similar to how like Filecoin and IPFS works and so on and so forth. But now it's actually integrated into the layer 1 of the BNB chain, and it's going to be pretty cool with what we can do. Artificial intelligence scripts and different ways of making data public and private, and hosting different sorts of DApps that kind of manage storage, or NFTs or dynamic NFTs using external code in smart contracts to interact with smart contracts on layer 1. There's going to be so many different things that we can do. We have a lot of articles coming out in the future. So I wanted to focus this workshop on solely working with Solidity. So in the very beginning, what I'm going to do is just kind of go through a Solidity refresher for like the first 15 minutes. So you can skip this first 15 minutes if you're watching the video. If you're here, I'm going to go through that first. Just to kind of give you a complete overview of what is in Solidity and what we can do. Afterwards, I'm going to kind of go through the contract layout of PancakeSwap, and we're going to start basically interacting with an existing set of contracts, and we're going to record that data, and then we're going to try to interface with that data using the Block Explorer. Right afterwards, we're going to import some of these into Remix just so that you can understand how to interface with Solidity contracts that have already been deployed on the blockchain. So if you wanted to interface with PancakeSwap, you could, but then I have to kind of show you how to interface with other contracts. And so then I'll do like a brief Solidity tutorial on how to interact with existing contracts, as well as interacting with interfaces that you personally build, or with the interfaces that other people have already built and have already deployed. This might be trivial for some of you, and there's already a lot of tutorials out there, but I've compiled a lot of language and a lot of things that have been out there in this last week to try to bring you a really consolidated tutorial that could all be used on the BNB testnet. And there's a really nice flow that we're going to be able to go throughout this entire thing. And then lastly, I'm going to give you the resources that you can use for taking this knowledge and start creating your own React application. There's a challenge that I've made in React where you can deploy these contracts, the same ones that we're working with today, do some Hello World programs, but then you have to kind of think about doing the contract interactions on your end. So everything that I show you today, you can do the challenge inside of this workshop so that you can do what it basically says, which I'll get back to later. We're going to be trying to send money to charity, so I'm going to leave that as an open-ended challenge at the very end of this. But if you can understand this lesson, then doing the challenge should not be that much more difficult. It is hard, but this is the fundamental backbone of what you're going to need to know and how to do in order to do that. Okay, so that's the preface. Let's just jump right into it. Okay, I hope everyone's okay. I hope you're doing well. Happy holidays and everything else that's happened in the last week. I know Easter and Ramadan and you know, so many crazy things in the world. So we get to finally have and take this time together to just like focus on, you know, shit tokens. Let's just talk about tokens and NFTs for just 1 hour each week because our brains need a rest. So cheers. I have a Red Bull that's not sponsored. Let's begin. Okay. So you can see my screen. I have my notes right over here, but I'm basically going to kind of just do what I did over here and put it over here and to show you. So the first thing that we're going to do, I'm basically going to show you how to write in Solidity. And Solidity is a smart contracting language that you can interact with the Ethereum as well as the BNB blockchain and other blockchains that are EVM compatible. And once you deploy a contract, you cannot redeploy it. You can't not like edit it. You're going to have to redeploy it if you want to edit it. So that's why we use a testnet. And if you're not familiar with what a testnet versus a mainnet, it's basically like your testing environment for deploying applications and then being ready to then move it over to mainnet once you think you're production ready. So we're doing everything right now in the testnet, and I'm using the Remix IDE to basically interface with these contracts in a test environment. I have my MetaMask installed, but I also have the BNB Chain testnet. I got some BNB tokens. And this entire tutorial, you know, I see on Discord, we have a lot of people asking how do I can get more BNB test tokens, but I've gotten like up to 200 before BNB tokens, which was kind of crazy. And that's because of this process that I'm about to show you. So if you want to learn how to make more BNB test tokens and get them, this is kind of the tutorial that you're going to want to watch. So you never run out of test tokens because I've been able to accumulate a ton of them. So anyway, so when we create a contract, we have to make sure that we start with Pragma Solidity and then we choose the version of the compiler that we want to use. Over here on the left side, we see that we have our contracts and everything else, which is our scripts, our tests, our artifacts. These are automatically going to be created once we import contracts from other deployed contracts. So you don't even have to worry about that. Solidity and Remix handles all that for you. I've been making some contracts on my own, but here on the left, you can see that there's a compiler. I've chosen the 8.19 compiler, which is the compiler version that I'm choosing right here. So you would have to use the same compiler. You would compile the contract once you were done, and then you can actually go here, connect your MetaMask, which is the injected MetaMask provider. Boom, and then it would connect to my testnet. And this is the account that I'm using. So just to check, it says 0.49 at 0x6545, and that's the one that I'm using right now. And then I'll show you how you can then interact with this. So now that my MetaMask is actually plugged into Remix, I now have full control. So the first thing that we always do when creating a contract is that we say contract, and I'm just going to basically call this, we're just going to try everything out. So I'm going to try it out, contract. We end with curly braces as always, and this is standard. So there's a lot of different variable data types, and one of them is uint, which is an unsigned integer. And this is in all programming languages, and I'm going to set the variable to a, and we end all of our type definitions with a semicolon bracket. And then now you want to interact with this. So I want to update and do an external function call to read and then update the data in this contract. The contract is try it out. The integer is a, and now I want to do a function where I'm updating a, okay? So how do I do that? Function. Function is the key word. I'm going to function with this contract, and I'm going to update. This is my variable name. It can be anything. I'm going to set in my parameters. My parameters are my arguments. And argument, I'm going to say uint, because that's the argument that I'm going to try to interact with based off of a. Simple. And since I don't want to shadow this variable a, I'm basically going to do an underscore a. Lots of people do this in Solidity so that they can essentially interact with other variables that they've already created. but they don't want to shadow the variable, so they'll just do this underscore. It's better that you do this. That's why you're going to see in a lot of contracts that you read and write, you'll see a lot of code that does this. So this is a way to reference variables that are the same without calling explicitly that variable in your contract. Okay. And then since I want to make this an update from outside the contract, I want to make this function available to anybody to call. I'm going to say external. And then just like before, I'm going to make a curly brace and I'm going to say a, my variable, a is underscore a, which is the argument that I am setting. So if I do this, I want to now update it. So I'm saying, hey, update a with underscore a, which basically means whatever I input here, you're going to see if I'm putting in the number 5, a is going to then become 5. Okay, because I'm saying a equals underscore a. This is where I'm going to put in that data. That data is equal to a. A is an unsigned integer. A on the blockchain is now 5. Okay, so how a lot of object-oriented programming works. So when I say function and get, and I'm going to get this number from the blockchain, I'm going to say external so anybody can call this function, view so that anyone can actually see it. And then returns is the keyword for actually returning that variable or whatever return type that I'm looking for. So you use the returns keyword. And then since I'm looking for a uint, I'm going to say uint. Now I'm needing to make my function, and inside, it's a little of a brain tease, but when you do return functions inside of a function or the statement, the type word, it's just return, not returns, plural. I'm going to say a. This should work. So if I save function, I spelt function incorrectly. Hold on, function. Update external. So this should be fine. And it's saying that it's giving me not an error, but it's just saying, hey, you need to update the license. So I always just kind of like copy and paste this license, and it always wants you to add a license at the top here. And then it's saying invalid SPDX license identifier contracts into contract. The reason why it's saying that is because my contract.sol is not the same as try it out. So I'm basically going to just like rename this. I'm pretty sure that is the error, try it out. And if I save that, it's not looking like I'm doing too good. So what do I need to do? Well, technically, I'm not even finished building out my contract, but if we see what this is, invalid SPDX, oh, I need to get rid of these. And then it says function A, external, identifier not found, function update A. Yeah, so A is inside of this call back function. Yeah, so as a example, what I'm trying to do is basically say I want to set the argument underscore A and make an external call function outside of this contract. Yeah, so this is how I would then update a value, return that value, update it and then get it, and update it and get it. This is what I'm attempting to do. So function update, am I just writing something wrong? I am pretty sure I have this correct. Let's see, external views, returns, return A. Yeah, there's nothing wrong with this code, technically speaking. Anyway, not sure what's happening there. So that's one thing there. I'm not going to focus too much on it. I'm just trying to blast through Solidity for you. Contract, and I'm going to make a new contract, and I'm going to just say like try it out 1. Okay, so this is another contract. All contracts, they're either wallet addresses or they're smart contracts. So EOA addresses are, you know, contracts for me, my wallet. So my wallet is, it has an account as well, like I showed you up here. But then I also have a smart contract that also has an address. So if I were to deploy this contract and it goes to the blockchain, Well, technically, it also has an identifier. It also has an address, which I'll show you later when we go to the block explorer. So I'm going to say that the address, which is a keyword, and then I'm saying the owner. So the owner is me. I'm trying to say that I am the owner. And anytime that you want to set something when you launch a contract, like I want to say, hey, this contract comes with these nice things when it first gets out there. Well, oh, I know what I did wrong. You know, it's always a syntax error. Uint. Okay, that was my error. You probably saw that before I did, because I'm an idiot. So address owner, and then I'm gonna do function, and I'm gonna say, constructor. So constructor is the way that I actually set things, if I can spell, constructor. Oh my God, constructor. I'm so used to working on a laptop. So the address that I want to pass is going to be, again, underscore owner. And I'm going to also set this with curly braces, and I'm going to say that that owner is going to be owner. So owner equals underscore owner. So this is basically me setting the value of owner to the address, which is going to be me. And there are ways to kind of establish this. I can say that the message.sender, which is basically spelt like this. So you have message.sender equals owner, right? I can also say this where if whoever actually deployed the contract is actually the owner of that contract. So anyway, I'm not going to get too far into it, but that's one way of doing it. So that's just to show you constructors and how those work. If I was to make another contract, this contract would be like, let me say, try it out too. And I'm going to say address owner again. And now what I want to do is I want to actually start working with finance. So there are functions that I want to create. So I'm going to say that there's going to be a function, and whenever I want to actually send money to another, you know, say like another contract or another wallet, I would say deposit. And so this is just the function that I'm creating. This is not a universal thing, but if I wanted to make this function called deposit, send money, I then have to use the keyword payable. And this allows it to basically send BNB tokens if I'm calling this function. And since I want everybody, again, to use this contract, I'm going to say external, just like before. And I'm going to close it off just like that. So that's function. Now, if I wanted to actually send this, let's do function, and I'm going to say send BNB tokens. And I'm going to say how. I'm going to say, well, I'm going to send it from to the recipient. So I'm going to have to say address, who is a recipient, and I want to pay that address. I'm going to say it's payable. And then I'm just going to name this variable 2. So that's my first argument. And my second argument is going to be the amount that I want to send them to. So I'm going to say amount. Okay. So everything that we're doing so far, you've already seen. Now I'm going to say, now I want to make a low level function where in this function, I want to essentially say, take the true or false value of whether or not I sent any data at all. And whenever I call this function, I need to make sure that the value matches the amount that I'm actually sending. So this is a way of basically stating of whether or not I'm actually truly sending BNB tokens. So the way that I would write this is I would first start the call to say bool, and then I'm just going to call this boolean value sent. And then I'm going to do a low level check. And to check this, I'm basically going to say memory. Memory is a way of kind of looking at what's already available to the contract and knowing whether or not this contract is doing what it says that it's doing. And so I'm going to set this value to data. And what I'm going to do is going to create, since I already said 2 is the payable address. So I'm going to say that I am sending. Okay, so sent is going to be equal to 2. So I'm sending, and then I'm going to call the map value. So I'm going to say value is set to amount, and within this I'm going to basically just kind of end it there. All I'm really doing again is just saying whatever the amount that I'm setting, which is this right here, to this, and whatever I'm sending it to, I need to make sure that the value matches to the amount that I'm actually sending. And whoever I'm actually calling it to, it needs to make sure that it's sending it to the appropriate address that I'm putting in. So this is basically just like a checksum. So it's making sure that whoever I'm actually sending it to, the value equals the amount that I'm actually putting in. Because I don't want to basically kind of send something and then have other people send money on my own behalf. So this is a good way of checking for that. And there are other ways to kind of do error checks, but the reason why I'm showing you this is because 2 things. I want to show you that you can create other parameters or other arguments within the parameters themselves. And then you can actually create an instance of that function and to do something very specific before you actually call this function. So instead of just simply saying, all right, update this value and then get that value, you can actually make sure that the function will do what you are trying to make it to do. So this is a good way of doing error handling. Yeah, and then plenty of ways to get this to work in the way that you're looking at into. So this is a pretty standard way of writing a low-level function. Look into low-level functions on your own time to see like how to write better low-level functions so that I want to send BNB to somebody. I really need to make sure that it's going to send BNB. So I would write a low-level function to make sure that this function works the way that I'm intending it to. Otherwise, it's an insecure function. This says it's unused local variable. This is not the point. So I am going to move forward. Now, again, more on Solidity. If I'm going to say, create I don't want to create a contract. I just want to create functions that I can interact with, that are not inside of this function. So now let me show you what I'm talking about. So this is called an interface, and I want to interface with other contracts. So I want to interface with like try it out 2 or something. So for example, I would create an interface. That's the keyword. Other contract is I want to interact with another contract. That's pretty standard to see that it starts with I. The contract starts with I, and interface is a lowercase I. I'm going to say function. I'm just going to do bar, and I'm going to make this payable function. An external function that anyone can see, and it's going to just return a uint. So if I can't actually make any functionality within this interface, all I can say is that this is a function that will do an external view returns, and it will return an unsigned integer. So instead of me writing this particular function within my contract here, this could spend more gas. Instead of me spending more gas in my contract, I'd rather just use an existing interface and use that interface's functions, and then take that function body and then do something different with it. So this is a way of abstracting the way that we actually interface with functions. This is also important if you don't want to be rewriting functions over and over and over again, because the more functions that you have in Solidity in a contract, well, it just spends more gas. Okay. Don't worry if you don't understand what that means. But that is the kind of the key and purpose. So interfaces are really important because it's going to save you a lot of time and hassle. And again, in the last half of this, I'm going to show you what all of this, how it all means when we put it together. None of this is supposed to kind of really work. I just want to show you what Solidity is. So contract, and I'm going to say try calling this contract, and I'm going to try to interact with this particular interface now. So now that the interface exists, I want to try calling that interface. So I'm going to say a new function. Since I know that it's bar, I'm going to say function, and I'm going to call this new function foo, and I'm also going to make it an external function. And within it, I know that this bar contract or this bar function is expecting to do an external view returns of an unsigned integer. So what I'm going to do in my foo contract function is I want to bring back the value of bar. So what I would do is say result, and that's just I'm going to say unsigned integer result, and then I'm just going to say other contract, and it already sees that it's here. This won't be the case if you weren't working with that contract directly or the interface directly, but I'll show you later. So now, for example, let's say that I've already deployed that interface on the blockchain. So let's just pretend that that contract's address was my address. So I would basically just kind of paste it here. And then what I would do is do dot notation. And since that contract is now aware of that interface, I'm going to call bar. See, it says bar, it's aware of bar, and I'm going to call that bar function and put in the arguments that I want to put in. So I can either fill those arguments with already seeded arrangements. So say if I wanted to add like an unsigned integer and an address and a few other integers, I could. Okay. So, and there's lots of ways to actually then interact with this interface. For example, there is like, I have this. There's message, oh my God, my caps lock. There's message.sender. Again, I showed you this. Message.sender is like a way where an address that is called by the function. And so this is typically like me, for an instance. When I showed you that there is an owner, I can say that the sender is the owner. So whoever deploys the contract, who's the sender, is the owner. That way I have control of the contract. There's another one I can do, message dot value. Okay. And message dot value, what this does is it essentially assesses for the amount of BNB that I am sending within a given transaction. So this is how I assess for the value that I am personally sending within that message or within that contract. And then there's another handy one. Let me just do, There's another handy one called block. Block timestamp, which is a pretty nice one. So block timestamp, this is a way where I can say, hey, I want to do like an ICO, for example, like make the minting of this ICO or make the minting of this NFT or distribute the rewards up until a certain block. So I can set the block timestamp to a future block that hasn't been created yet. And then once this timestamp hits that block, then I can say, all right, this is automatically going to tell this function to stop, which is also interfacing with this interface. So that's how you can get other contracts to work with one another, as well as making the functions aware of what's happening to the state of the blockchain is by using the block timestamp key phrase word. So that's that. And then of course there's this other keyword called this. This is how you can refer to something that is within the scope of the contract. You can either say it's the scope of the function, or you can say it's within the global scope of the contract itself. So I can typically, what I would do with this is say address, and then I want to state that it's this particular address that I'm talking to, and I want to say that this address, which could be my address, like the owner, I want to check on the owner's balance. Okay. And it would know what it's referring to. Okay. So last but not least, this is a lot. I'm just going to delete all of this. And the last thing, I'm just going to delete everything up until here. And the last couple of things are like with arrays. So with arrays, I can do like, unsigned integer arrays, and there's other data types like booleans and signed integers and so on. And I want to call this my array. So what is an array? It's a collection of one data type. So I can have multiple things inside a structure, and within this structure I can say there's the value 1, 2, 3, 4, 5, 6, 7, starting at index 0, 1, 2, 3, 4, 5, 6. So if I have numbers 1 through 7, it would start at index 0 up until 6. So 0 equals 1, 1 equals 2, 2 equals 3, and so on. And so now what I can do is I can turn this array and pass it to a function as well. So I can say function, and I'm going to make this the add function, and I'm going to pass an unsigned integer, and I'm going to pass this a value. And within this value, I'm going to make this again an external call, and I'm going to say my array, and we use the keyword called push. So this is similar to like JavaScript. And then I can pass in that value, and whatever value that I then add, I will then be able to add that value to my array function. So if I add the number 8, it would add it at the 7th index of that array. And there's all sorts of things that you can do when it comes to like, looking up for values if you need to use an array for this. Okay, so that's the array. There's other things that we can do. I can say function update this array, and I can again pass in a uint and another uint value, and also make it external, and then call my array. And at whatever index, this is how you can specify which number within that index. So I can say this index I is equal to the value. So what I'm saying here is like choose a particular index, int, right, I. So if it's 0, 1, 2, 3, 4, 5, and the values are like 3042, 130 or whatever, then I can say, okay, at index 1, I want to change that 4000 number to 20. And so that's what this would do. So that's kind of an example. Now, if I want to completely get rid of a number, I can just do function, and I'm going to call this destroy. And within the destroy function, I'm going to say uint. Again, I'm going to select a particular number in the index, and then I'm going to say delete. So this is the delete keyword, and then I can say my r, and again at the position that I am then calling, which is at I. So this function is going to say, okay, you're passing in the number 1, which is going to be the 0, 1, so it would be the second number in the array. And you're going to delete that number because it's saying your array, which is this array up here, it's going to delete that number at that index. So that's how you can remove numbers. So instead of the remove keyword in Python, you could use delete instead. There's another one. I'm just going to say remove the last variable. So there's some special key types. So I can say last value, and I'm going to say, this is also an external call, and then I'm going to say my r, and then there's this keyword called pop. It's a function, and this would basically remove the last value of the array. So whatever the 5th, which could be the last index, whatever that ends up being, could be 1000. It's just going to completely remove that from the entire array in total, and then it would shorten the length of the array as well. Okay. Last but not least, this is basically all you're going to ever need to know about like Solidity in the very beginning until you start getting really complex with things, but a majority of your functions are going to be within these things. Just get really comfortable with functions, basically, is all I'm trying to say. You got arrays, you have contract, you have constructors, you have, remember, you have arrays, sorry, you have like message.value, message.sender, the block timestamp. You have all of these things available to you, but it's up to you to figure out how you're going to kind of amalgamate these things together to create really interesting functions that are going to do exactly what it is that you're needing it to. So if you want to set a value, again, you're going to have to use a constructor as soon as the contract is deployed onto the blockchain. You can never update it, so you're going to have to redeploy it. You use functions, which anybody in the world can call. You can call them using the external keyword. Again, if you want everyone to see it, you can say view. You can also allow certain functions to send actual tokens, which is using the word payable. I hope it's starting to click because all the keywords match to a particular functionality that you're looking. So you write functions that issue that functionality, and you're setting up variables in the very beginning, like how I set up my array to do those sorts of things. So now I'm going to do another one, and I'm going to call this this is a map. So a map is basically a way of doing key value pairs. So a key is a value. So my hand is my left hand. So for one hand equals either left or right hand. So I have to specify the value. It might be a hand, but it might be a right hand or it might be a left hand. I can specify the value. So let's do a map. So you would say mapping. And now I want to map, say maybe my address to a particular function. So what I'm going to do is going to say address. I'm going to map a particular address, like my address, to the values of my tokens. So I could say like uint, so I can get that number. I'm going to call this map balances or balances. So now I have a map called balances. Its key is address, and its value is an unsigned integer. It can never be anything other than unsigned integers now. Okay, I would have to create a new map with a different variable name to do something else, like maybe strings or so on. So I want to update this map. I'm going to do function update, and I'm going to say address. And again, I'm going to use the owner keyword. It's not a keyword. I'm just naming my address owner. Okay. And then I'm going to say the unsigned integer, and I'm going to say amount. Okay. So I'm taking in two values, external, so that other people can call it, remember. And then I'm going to call that map. It's called balances. And I want to get the owner. So the owner is going to be matched to the amount. So whoever the owner is, that key, that address. So I'm going to paste in my wallet address, and I'm going to put in like the number 12. So I'm calling the map keyword, and I'm going to basically say whatever I put in for that address has this amount equivalent to it. Map. Okay. And if I want to remove all of the owner's balances, I can even say like delete, balances of that owner. So then all of the previous balances are then gone, right? Before I actually update it. So I can't have ever more than one amount per owner. Something dumb like that. Anyway, you can even specify which address. I can even put in my personal address here and then say delete all the balances of this person's address according to this contract. So that's how you can make use of actual accounts. So that's basically all of Solidity that you're going to need to really kind of think and work with. So now that we have seen Solidity through and through, the next thing to really do is to actually start interacting with contracts. So now that you've seen contracts, you're familiar with like what the language is all about. Now, what do I want to do is I want to be able to interact with contracts, because I like to make my own functions that I can interact with existing deployed contracts. So when I usually want to say, like, say if I want to remake PancakeSwap, right? And I want to be able to, I don't know, like use one of the swapping functions that are already deployed on PancakeSwap. Well, like I said before, there's a way where I can create a contract and I can use that swapping function and I can use it as my interface that I can then interact with. But I need to like actually go and find that particular contract on the blockchain. So how do you do that? Because a lot of people might want to use existing pools that are already out there. Like people want to use Uniswap now that it's on BNB. So I want to create a contract that, you know, does some really interesting things with my BNB token before it actually deposits and stakes it to Uniswap in one of its pools or something. This is a way where you can start getting interacting with other existing contracts to do even more complex relationships on the blockchain, which could create entirely new applications in of them themselves. So, yeah. So how? So, well, what you do, and I have an example here. Same thing I was saying today is you're going to want to first open up the Remix, you know, IDE to start doing this, and you're going to open up like testnet. You know, I'm going to basically get this open right now. So this is the Block Explorer testnet. If I want to look up a particular contract, I have to actually know what that contract's address is. So if I want to be interacting with the contract specific to PancakeSwap, right? How would I do this? So what my method is, and what I was learning for the past couple of weeks is like what I need to do is just maybe I want to do a very specific thing with PancakeSwap. So in this example, I was thinking, okay, I want to add tokens to a staking pool. I want to then harvest those tokens for rewards. And then I want to deposit the rewards to a charity wallet, right? So I want to write a full contract that does all of these things. But how am I going to get access to the liquidity? And how am I going to use that contract and use its harvest function? And then how am I going to automatically deposit those tokens to another contract? So I can write run contract that does all of this, but I'm going to need those contracts interfaces. In order to know where those interfaces are, I need to use BScan. And in order to use BScan, I need to know the contract's address. Okay, so how do I get that contract's address? I just use it. So like I said before, my first step is that I want to select farms. I want to get the BNB and BUSD liquidity pool, and then I'm going to view that contract. So if I go here, I'm going to go to liquidity, and then I can say like add liquidity, and I'm going to select BUSD. I don't have any, surprisingly, so I'm actually going to have to swap for some first. This could be a better example even, actually, too. So I'm going to do like 0.0001. I'm just going to get some BUSD. It says that the price impact is too high. Okay, so I'm going to do that much. I'm going to swap it. I'm going to confirm the swap. And right here, what you can see is that there's a multi-call function. This is the contract that I'm actually interacting with. This is the contract's address that I can view in the Explorer. Now on testnet, the problem is that if I click this right now, sometimes it's not going to open up this particular contract in the Explorer, but sometimes it does. So since it did, this particular contract is the one that I'm interacting with for how to swap my TBNB to BUSD, right? So if I want to actually look at this contract, I can see all the transactions that people have done today. I can look at all sorts of things, like what are the, I know that it's a BEP20 token, but this is what I want to focus on is the contract bar. So here is the contract's address. Like I said before, that is the contract address that we want to interact with in order to interface with. Okay, and then I can see that the contract's name, when it was originally deployed, it was called Smart Router. I know the compilation version that it's running, so that's important for me. And I can also see that it was interfacing with all of these other contracts. So just for the sake of time, I can't run through all of these contracts, but these are all the contracts that PancakeSwap interfaces with in order to do certain functions. So let's go back. Let's see what is the function that I'm using. It's called multi-call. I'm not sure what this exactly means yet out of all these contracts, what one is actually doing. So I'm just going to confirm to see. So I might have to do it one more time. Okay, this is it. So I got to actually see the transaction. This was from my address. And if I click to see more, I can see that it was the multi-call function. It has like this deadline attribute. It has this like bytes data attribute. What it was doing, which it basically just, like right here, I was using TBNB to get BUSD. Here's the same contract that it was interacting with. And I was getting BUSD right here. So this is how I know that it was giving me all these things. Now, I can even get those particular tokens contracts as well. So if I wanted to go and get the Binance USD address, I would just have to click here, and here's the contract. So it's 0xAB1A4D. And trust me, I've stared at this a million times, so I'm almost I memorized half of these contracts. So whenever I see AB1A, well, I'm like, all right, that's BUSD on testnet because it's the same address. It's never going to change. And I can even see it here. It's literally, it was called a mock token. They deployed this mock token, and this mock token is able to, when it was created, it was constructed with the Binance USD as the BUSD token. And it's using the ERC20 instance, which is this right here, ERC. And it's implementing the interface of IERC20, which this is the interface. So it says you can get the total supply, you can transfer, you can get the allowance, you can get the approve, and see how these functions aren't really doing anything. These functions are just saying, you know, what is the function's body? That's it. And it's up to you in your smart contract to tell what, you know, what is this interface's function going to then do? Are you going to use the transfer from function? Okay, well, if you are, you're going to have to put in the address, the from, the to, the amount, and then know that it's an external returns and it's returning a Boolean value. And that's it. It can also emit events too. So events are basically like how you can tell if something actually happened on the blockchain. And it uses all of these other interfaces. So I will show you in a couple of moments how to actually use these in Remix. So again, when I go back to this, I think it was this one. Yeah. Let's go back. Okay. So I'm going to go take a look at this particular contract. So this is the contract that I actually interacted with. So I can copy this. And just for now, I can just paste this here. So this is the contract that I use, and this is how I normally do it. I'm saying like, okay, this was my BNB to BUSD contract. So this is the contract address that I used to swap TBNB to BUSD. So this is what you need to do. You got to get those contracts addresses, but then also you have to be aware of what functions was it actually using in order to do that call to begin with. Well, I know that it's the multi-call, so I have to go and find that. So I'm just going to copy this. I'm just going to say multi-call. I'm going to copy that. And I know that the functions is, the method ID is 0x5AE. So I'm just going to keep that in mind, 0x5AE. And just so that I can keep it here, I know that the function was called multi-call. And I'm just going to get the function's ID and paste that here as well. So I know where I can find it, and I'll show you how. So when I go back, I'm going to go to contract, and now I can do Command F if you're using Mac. If you're not, I think it's Control. So I'm just gonna type in, what was it called? The function multi-call. Yeah, so I'm gonna take a look at multi-call, and it brings me straight to it. Fastest way to kind of take a look at these things. So if I read this contract, I can see that it is an abstract contract that is also calling the interface called multi-call. So what that tells me is that if I'm going to be using this particular function, I also have to call the interface of multi-call as well, which is a function where all it does is taking in, again, the bytes of that data, and it is returning the result, which is what it was doing before. That's what we saw. It's doing some, crazy things, and that's all I need to know. So now I actually want to use this contract, right? So I know the contract's address that uses this, but now I want to actually use this contract, right? So I'm going to do a few things. I'm going to actually copy this to my clipboard. I'm going to go back to Remix. And I'm not going to put it in my contracts folder. I'm going to make a new folder, and I'm just going to call it interfaces, right? Okay. And within interfaces, I know that I am going to, well, if I go back to here, I can see that it is importing from interfaces multi-call. So that just means when it was deployed, this was what was written in that person's project folder. This could have been anything. It could have been interface. It could have been like Diablo. It could have been anything. But they called it interfaces. I'm just going to follow the same convention. So that's why I said interfaces. I can see that interfaces was using the multi-call. So where's multi-call? I'm going to go after that one first. Actually, I'm going to do the multi-call one first. So I'm going to actually put that in my, let's do contracts folder. Oops. Nope. Let's do contracts. I'm going to say multi-call.sol. And I can literally just copy and paste this contract and put it in here, and it should work. So if I take a look, it says found. See how it says it needs to find the multi-call instance? So how would I do that? Again, I just go here. I'm just going to put in And where is it? I just got to scroll down a little bit. And here's the multi-call interface. So all this is doing is using the multi-call. And this is exactly what we saw on the Block Explorer. So this is what I was using. It even tells you how it's going to be used. It's going to call multiple functions in the current contract and return the data from all of them if they succeed. Dev, this is a note usually to the developer. The message value, which is the amount of token, should not be trusted for any method callable from multi-call. The parameters of this, the encoded function data for each of the calls to make this contract returns the results from each of the calls passed in. So it's just like giving me a heads up, right, on how to actually use this. So I'm just going to copy this interface, and I'm going to go back, and I'm going to go to interfaces and create a new contract, and I'm going to say multi-call as well. And I'm going to paste this in. And if I spelt it correctly, I'm just going to make sure that I did. I'm going to copy this and rename just to make sure that I have it spelt correctly. And see how it created the build info as well as the artifacts for me anyway. Now, if I go back to multi-call, now I'm not getting any issues because it's realized, oh, you're looking at interfaces and you're looking at the interface, the multi-call interface. So that's how I can import other contracts, okay? That's with using existing contracts that have already been deployed. Why am I showing you this? Now, what I'm going to do is show you how to make two separate contracts that might live inside of the same project's directory and have them interact with one another using interfaces as an example. Because it's important that you know how to go to the Block Explorer to interact with certain interfaces that you're going to need. For example, I know for a fact that the I non-fungible position manager is really important for interacting with the pools. So if you wanted to deploy or add liquidity to the pool, you would have to be using the I non-fungible position manager. Okay. So let's do like a very simple example, because if I'm going to have to spend the next 10 minutes to show you how to recreate all of the pancake swap decks, I'm not going to be able to finish in less than 2 hours if I'm lucky. So what I'm going to have to do is basically show you exactly how you would do it using a pretty basic example. So this is the last part. So I've explained to you so far of how to interact with the contracts and how to take those contracts from the Explorer, how to find them by using the exchange themselves, get that transaction ID and go here. And, I was using, the actual I finder, but remember I had a method ID as well. The method ID that I was using was this OX5AE. So if you needed to find the exact function call, what you could do in the Block Explorer is you can actually write directly to this contract. Okay, so I can connect to Web3 with my MetaMask by connecting to Web3, choosing this, connecting to the actual Block Explorer itself, and see how each of these have that little identifier. I'm just going to find the one that I'm looking for, and it happens to be function call number 16. And in here, it's asking for the payable amount in BNB tokens. And for the deadline, which is probably what this means is like the block time on like how soon does this call need to be like done. So I would have to write a function that says like it's the current block time, and then whatever data that is in terms of its amount in bytes. I haven't messed around with this enough to know exactly how this works, but this is how you interact with the contracts directly. So you can put in whatever information here, and because this is the contract to this particular thing that I just used here on this is just a graphical user interface, and this is a way of directly interacting with those contracts instead of using this GUI. So if PancakeSwap never existed, you can still use PancakeSwap here. Technically. You can technically fork the entire PancakeSwap, all the contracts, all of the code, and make your own, deploy the exact same thing as long as you're under the right license agreements and everything that they have on their GitHub. You just follow the rules. But you can expose basically all these same functions, but you can rewrite all of them. You can call multi-call like mega call. It doesn't matter. It's just the same thing. You can organize it in whatever way that you want. This is how people make forks of other contracts and display them here on the Block Explorer. That is another way that you can do it. So that's how you can interact with smart contracts in this way, rather than going here. Now you're probably inspired to think, oh, that means I can make my own interactions. I can swap and then take that swapped amount and stake it and harvest it and harvest it and send it. That's what a unique smart contract would be. And you would create your own DApp that could do that. Okay. So that would be a totally different protocol, and you would write the contract that sets that up. Okay. So how do you interact with contracts and interfaces? Good question. Now I'm going to give you a pretty basic example, but I'm going to give it to you twice because it's not easy. So please try your best to follow along. I've shown you how you can save this data and how you can kind of like pathfind your way to success. This will be the last thing that I show you for the next 20 minutes. So thank you for sticking around. Cheers. Okay. Now we're going to get down to business. So I'm just going to delete this contract because I don't even need it anymore. So I'm going to call this, I don't know, contract A or something. It's better to kind of uppercase these things. So in contract A, I'm just going to get rid of these. In contract A, I want to set up a way where I can deploy 2 contracts, but have contract B interact with contracts A data. Okay, so I'm gonna start with Pragma. We're going back to the very beginning. So if you stuck around the whole time from the beginning to learn how Solidity works, just pay attention because this is gonna look easy now. 0.8.19. I can use that version contract, and then I can say contract A. Okay, and then within contract A, I want to say that the uint, okay, unsigned integer, is a public integer. Anyone can see it, and I'm going to say that the BNB price is, what is it, like 350 right now? I'm just guessing. Contract A, cool. Now, I want to say contract B is going to be aware of contract A's address. And then, like I said before, like I want to be aware of the swapping address, put that address in contract B, and call the data from contract A. So how do I do that? So contract B, okay? So I'm going to set the contract's address. So remember, how do we set something in a contract? We create a constructor. If I can spell just for one day, I'd be happier. So constructor, it's pink, so you know that it's a constructor. I'm gonna say address. I'm gonna set the address. Remember, I don't want to shadow my address, so I need to create an address first, because address, and I'm gonna say, I don't know, contract address. This is gonna be contract address of A. So I'm just gonna say A. Can I do underscores? I think I can do underscores, yeah. Why is this giving me a problem? Because I haven't finished, yeah. Okay. So, oops. So I'm just gonna say, hey, all right, contract B. I want you to create a variable of address, store an address inside of a variable called contract A address. So my goal is to try to store the contract A's address once I deploy it in this variable. I know this could be a brain teaser trying to think about, oh my God, it's like imaginary pointers, but you really got to think about it in that way. And then not to shadow it, because I'm not going to rename it the same thing, but I'm just going to say contract address A, but I want to add that underscore. So I'm not saying that it's the same exact thing. And now I'm going to say contract address A is equivalent to what I put in here. So I can set the constructor. Okay, and this can only ever be done once. So I'm going to say contract address A. So this is a way for, this is a constructor. The purpose of this constructor, it sort of acts like a function, but I'm going to set this constructor to say, okay, B, be aware of contract A's existence. So that's how I'm going to set that up, so that contract B is aware of contract A. Now, what am I getting from contract A? Well, the BNB price, it's 350 bucks. So I need to say, okay, well, since it was a public function, I'm going to make this one a public integer. And I'm just going to say, I'm trying to get the same BNB price. Okay, this is a different contract. I know I have two of the same, but see when I highlight this, it's the same. So that might be confusing to you, but this is a completely different contract. This BNB price is not the same variable as this one, since this is a totally different contract. Don't confuse it. I'm just saying, hey, contract B, you also have a variable named BNB price, but it's not set to anything. That's why I'm going to use contracts A variable to set it. So how am I going to do that? A function. Functions are great. So I'm going to get it. I'm going to get that function's number. I'm just going to call it get price from other contract. It doesn't matter. Okay. And then I'm going to say external, because why? External means I'm going to use another contract that's already there, that's already deployed. Okay. And so within this, I want to say contract A. So sort of like an interface. A is A. So I'm calling contract A. And how does it know that A exists? Because it's inside of my project directory. Similar to how when I multicall was complaining at us saying, oh, where's I multicalls not in interfaces? That's because I didn't put it in yet. But because A contract is in the same directory, I don't have to import it. It's right here. It's in the same file. So A contract A, I'm just going to call the variable. Doesn't matter what it is. And now I'm going to use contracts A's interface. It's not an interface yet, but I'm going to try to catch that data. So I'm going to say this same variable. So what I'm trying to set A to is this particular address. So I'm trying to fetch the data from this particular address. Remember, I'm setting the contract's address here, and now I'm going to fetch that data. So I'm going to say contract A address. So I'm going to fetch this address, which I've already set, because I'm going to deploy this first. You'll see in a second. I'm going to deploy it first, get that address, put it into the constructor, and this function, which is contract B, this function is aware of what that address was. And so now we're setting that address to contract A. Okay. Lastly is I'm going to try to get the BNB price, and I'm going to say contract A, which is this variable, and I'm going to get the BNB price, which is already made available to me. So what this is going to do is going to allow me to call this particular contract. So I just need to, I hate this SPDX thing, but this is important. I'm just going to paste that here. So now I have no problems. Compiler 19, we're all good. We've compiled. Now I'm going to deploy it. I'm going to deploy A first. And I know that A is A because I've written two contracts. And here's A and here's B. Even though they're in the same file, I can deploy this contract and then this contract. So I'm just going to deploy A. I'm going to spend a little gas. Okay, cool. So see how it says A, and if I catch the BNB price, it says that's 350. Cool. Well, this also has an address right here. It's at OX7A4, blah, 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 you know, whatever. That's its address. I'm going to copy that because I want to use it in contract B. I'm going to flip over to contract B, and now I'm going to deploy it. But see how look at the difference. So if I do A, there's no constructor. But if I do B, see how it asks me, hey, what's A contract A address? Look at that. Contract A address, underscore contract A address, underscore A address. So I'm going to put in the A address, which is right here. What is that going to do? It's going to set contract address, this right here, to whatever I put in. Copy and paste. Once I transact, what's going to happen is that it's going to give me the ability to create this function. This contract B has one variable and it has one function. So when I do the transaction, it's going to deploy the contract. And now I can see contract B. So let me just look at both of them here. So I can get the price of the other contract, but first let me show you. I can't yet because I haven't activated the function. So if I try to get, I can get the BN price here on A, which is 350, but if I try to get it here on B, it's going to come up as 0 because I haven't used the function yet. All I've done is activate the constructor. Now I'm actually going to use the get price from other contract, which is this right here. It's a non-payable function, but I'm going to get the price from the other contract, which is A. It's already aware of what that is because it's getting it from an external contract. It's saying, hey, use this A contract that I'm aware of inside of my project folder. I'm going to set the variable to contract A. I'm going to say, hey, use A to get this contract address. Okay. And from there, I'm going to set the BNB price, which is this BNB price, to this contract at BNB price. BNB price is coming from this contract. So this is basically allowing me to say, what this is saying is you can use any of the functions. So contract A is an instance of all the functions and all the things that are available here. So all the variables, all the functions, all the interfaces. This right here, you can see that it says contract A address, but I could have literally pasted in contract A address, but I didn't know it at the time. I didn't know what that contract's address was, so that's why I'm saying I'm just using the variable here. But now it knows what it is. So if I do get price, I'm going to spend it, waiting, and now I've gotten the price. It set the BNB price from contract A, because that's what this did. And then it's saying, all right, your BNB price, this BNB price, this BNB price, equals contract A, which is this address that I have already inputted from this constructor, get its BNB price, which is this. And then this little basically means like whatever the values of it are. It could have been a function, it could have been a variable, it could have been anything. And it's going to be 350. So if I get BNB price, it's 350 now. So this is a way of basically what I just showed you is saying, you deployed one contract, it was already out there, similar to like an interface or a multi-call, and then I made a new contract. I set the value of that contract to be the value, the address that it's going to interact with that particular contract, and then I'm fetching the price from that particular contract and making an instance of it, and then calling contracts A's BNB price and putting it here and just basically receiving it. Calls are free, right? I can do calls all day. But if I get price, it's going to be a function because all functions cost a little gas. So the smaller the function, the cheaper it's going to get. The larger the function, the more expensive it's going to get. So that is just one example. Now, when I deployed both of them, let's see. Solidity, the deployed contracts I use. Yeah, so.
Can I ask a question?
For sure.
Okay, actually, I wrote it in the message box. If you can look at it, maybe it's better for you. The last one.
You do not understand how contract B is aware of A. Yeah, so let's go over that one more time. So contract B is aware of contract A because in my constructor, how I've written it, particularly, it's all dependent on the style in which how you write your contract. okay? But I created a contract where all it was just setting the price of an integer, of a value. Contract B is really the bread and butter of this this whole example. But what I'm trying to say is I'm setting up contract A address, right? I'm expecting that when I interact with this function, it's going to interact with this contract. So what I did is that I deployed contract A first, and then by deploying contract A first, what happens is that it has an address on the block explorer. So for example, if I copy this address right here and I go back to the Binance scan, I can actually look up this contract on the block explorer, and you can see on 7 minutes ago I interact with it, and the contract, this is the actual contract itself. And yeah, so this is the contract's address, and it's not showing anything because I didn't get the, let's get the actual deployment script, which is somewhere down here. Anyway, if I got the transaction ID, I can actually take a look at the transaction hash and look at that particular call. So let me do it one more time just to show you. Let me delete this. I'm gonna go contract A one more time. Contract A, I'm transacting. What I'm doing is I'm just deploying the BNB price to 350 to the blockchain. Once I transact with A, I'm gonna establish that the BNB price is that. Now, if I look down here, what I can see is that the transaction hash is right here. And if I go back to the block explorer and use this, I can see the same exact thing we were looking at before, but I can view the inputs as anything. But the reason why this is all wonky is because I didn't put in a lot of information that I need to be putting in order for this input data to actually be constructed to look proper. But yeah, so this is the 2 address. This was the address that I deployed it from. And this is the contract that was then created. So this is the contract that posts that 350 on chain. And you can look at all sorts of data. There's really nothing to it because all I'm doing was just posting data. Now, what I'm going to do is go back to contract B, which I've created a contract that's going to fetch the address. So how do I get that address? Remember, it's OX3 now. See, this is OX3. I'm going to get this address, which I could have gotten here, or I could have gotten here on the testnet. And I'm going to add that particular address here to the constructor. So this is expecting, before it gets deployed, it's expecting right here that I'm passing in an address. And what I'm doing with this address is that I'm setting this address variable in contract B to the address that I am passing when I deploy the contract. And then after that, once I transact and I deploy this contract B, which just pops up right here, if I've tried to fetch the BNB price, it has no idea. It says 0. Yet when I do A and I do this, it says 350. Why is that? Because I haven't used the function yet. All I did is pass the value of the address, of the contract's address, to B. That's all I've done. So the only thing that this contract B is aware of is the address of contract A, the contract address, this right here. That's it. But if I want to actually update and fetch the price of BNB from contract A, I need to use the function that I wrote, which is to get the price from the other contract. I have to use the external keyword in order to fetch the price from another contract. And then what I'm doing is I'm saying A, because that's the contract that I'm trying to interact with. And this could have been interface. This could be anything, okay? But I'm saying A because that's the contract I'm trying to interface with. I'm setting up a variable, contract A, and I'm establishing that contract A is equal to all the values that are within that contract's address. So contract's address has already been established because I constructed it when I deployed the contract. So contract A equals OX3C4. Okay, so it equals this number. That's the first part.
So let me ask you a question here on the line A, contract A line. Okay. So if we say instead of A, let's say something different, C, let's say C. Does it matter? I mean, should it be A, the name of the contract?
Are you saying if I did this, C?
Yeah.
Yeah, it does matter because look, it's running an error. Not found or unique. Contracts and contracts A, it has no idea what contract C is.
Okay. So where does this contract B get the name of the contract A? From the blockchain or from your local thing? Let's say.
For this example, it's just from my local setup because I'm the person who deployed A and I'm the person who's deploying B. So when I say A, in this instance, it's aware of what A is because A is contract A within this contract. Okay. And
okay, so the reason is they are both in the same file. That is the reason, right?
That is the reason why I can call it directly.
Okay.
See, if I called this like apples, okay, then I would have to say that this is apples, and then that this is apples, and so on. And so now I have no more error.
Okay, I understood. So another question. Can we, if we don't have that contract apples, but if we have it on the blockchain, could we do the same thing? So
Yeah.
getting a contract from blockchain and saying that like that line apples contract A equals apples and so on. Can we do that?
Yeah. So that's actually what I'm going to show you next. Is if you're not the person who deployed the contract, hypothetically, if you're not the person who deployed the contract, how can you interface with a contract that you did not deploy? Now, it's very similar. The method that I'm using here, which is basically to try to get the price, I'm basically passing in the value, and I'm using a constructor to pass in that value so that contract B is aware of apples. I want contract, I can call this like bees. I want bees to be aware of apples. So I'm passing in apples to this address, contract A, which is apples. So I'm passing in some apples to the bees. The bees now want to go and get some apples because now that the bees know where the apples are, now I'm saying, now say, okay, now you know exactly what to do once you can get to the apples. You have all the same functionalities of apples. And now what is functionality of apples? There's only one variable in there. It's BNB price. And so I'm going to say BNB price within this contract equals contract A, which is this already. I told the bees where apples are. So I'm saying apples, go to apples and go get the BNB price. So this BNB price is this BNB price. Let me show you how. BNB price, and I say, what if I said, I don't know, ETH price, okay? What if I said ETH price? And I said ETH price. Now I'm good. So what I'm saying here is saying BNB price, this variable, is equal to the contract A, which is apples, and I'm saying ETH price, which is the only available variable in that contract. So now that we're tearing it apart, we actually get to see the layers kind of unfold. I hope that starts to make sense because I think what's confusing you is that the naming convention was the same. But when you break it apart, when you want to write a contract, you have to start thinking about contracts in terms of really only three things. What are you setting in the very beginning? What are your variables that you need to be consistent throughout the life of the contract? So I need the address, I need the price, and these are the variables that I want to interact with, the maps, so on and so forth. Excuse me. And how do I want to interact with that data once I get it? That's what functions are for. And so I get to make a function do whatever I need it to do. So I passed in an address to the constructor so I can make a function interact with that other contract. I'm the one who deployed it. Now I want to give you an example of what if I wasn't the person who deployed it. Okay. Give me 1 second. Yeah.
By the way, there's another question in the chat box. If you can check it, if you want.
For sure. Let's see. Okay. Small question. If I delete an element from an array, then it doesn't reduce the length of the array. Any specific reason for this, or this is the intended functionality? So you're saying that when you... So there's two ways to remove elements from an array. You can either delete them or pop them or remove them. So you can... so it depends on what function that you're doing. So if you said that you're deleting an element, then you're deleting the value. If you're removing an element, then you're popping the value either at the end. And if you are, yeah, so those, I think, did I say all of them? Yeah, so it's delete, pop, and you can also replace the value. I want to remove the element from the specific index. Is this possible? Yes. So like I was showing you before, you take your array, you do your square bracket, and you specify the element of that array. Your function is going to ask you at like your parameter, the curly braces of your function is going, all right, what is I? And then you're going to say I is 2. So 2 means 0, 1. So it's the first index. And that is going to be the element that is removed because that's the second index. So you're saying I, and then that's the element that you are then going to interact with. And then you can say delete I, whatever that element is. So in your function, you can say delete this particular index at I. So if you use delete array I, this only deletes the value but doesn't reduce the length of the array. So you're saying, yeah, so if that's the case, then delete is removing the value of I. It's not deleting the value of I. You're saying that you want to completely remove I from the stack of the array, it sounds like. So I think that's a little bit more tricky. If you're going to remove a particular instance, then you're going to have to create a kind of like a for loop. Wherein then before you pop the actual index, you can loop through the array and pop, or sorry, pop that particular index. But I think that will cause an error. I think Solidity is a little weird like this. It doesn't like shorten the array. What happens is that you have to create a new instance of the array where any time that there is a 0 as a value within the array itself, create a new array where all instances of 0 across all of the i's are not included in the new array. So you would just have to create a new array. You would have to set the value of your existing array to the value of the new array. That's how you would do it. You see, got it. Yes, right. That's kind of a workaround then. Writing the for loop and then creating the new array. Yes. Thanks for clarifying. No problem. Yeah, so that's how you do that. Okay. Let's move on. Do I want to do that? I feel like that's not going to be helpful. Okay, let me do this other example instead. Okay. Let's do this. So I'm going to make a new contract and I'm going to call this contract B. Okay. So here in this instance, what I did is I used apples and bees, but this one, I'm going to create a completely different contract that's not a part of the same body. So this is the same way of thinking about it where if somebody else deployed it instead of me. Contract A. So contract A, oops, contract, I'm going to name it literally contract A. Now within this, what I'm going to do is, the first thing I'm going to do is call a function from another contract. Okay, that's the first thing. Second thing is I'm going to import, which I'll show you how to do. And then I'm going to actually interact with that contract's interface. Okay. So let's show you how to do this. So just like before, what I'm going to try to do is set up my contract B. So contract B doesn't have anything in it. So I'm just going to write pragma solidity 0.8, oops, 0.8.19 contract, and then contract B. Cool. What's wrong? I keep spelling pragma wrong. We all do this. Okay. I'm just going to get this license, paste it here just so I can get rid of that error. Okay, cool. So contract B is going to be the interface and contract A is going to call functions from that interface. That's the idea here. Okay, so in contract B, what I'm going to do is just set up that interface first. So contracts and interfaces are basically, they're kind of the same, but functions in interfaces don't actually have any real body. They just really have like the parameters and what they're supposed to do. Let me show you. So in an interface, what I'm going to have is, I should actually name the contracts interface the contract itself. So I'm going to say contract B instead here. And I'm going to name this contract just B. Does not matter. Let's call it B's just to make it easier. Contract B's. And within the interface, what I'm going to say is function, and I'm going to say, you know, hello bees. Oops. Hello bees. And it's going to be external, and it's going to be a pure function, which basically means that it cannot change. And it's going to return me just the string of hello bees. So I'm going to say string and whatever is contained within the memory of this function. So we went over memory before. So the memory keyword is going to be used here as well. And then within this, I'm not going to store anything at all. So where am I going to get this hello bees? Let's make it capital. Where am I going to get this string from? Right? So I'm just going to close this here. Now, this is just an interface. I'm going to use this function in contract A. But let's write out what exactly the function of hello bees is. Okay. So somebody in the interface wrote and said that hello bees is going to be an external pure returns, again, string memory. I'm copying the same exact thing. And this is going to return the string of hello bees. Oops. Hello bee. Hello bee. And it might have another function. It doesn't matter. The function can be anything. And it's also going to be external. And let's just say that it's something. I'm going to show you what this means in a second. So we have contract bees and then the interface in this contract B file. Okay. Now, let's go back and say this is something that exists outside. This interface is going to be able to interact with these functions here in a second. So let me show you how that works. There's nothing you have to remember right now, just follow along. What I need to have happen is I need the interface of B to interact with the address of B, and then the address of B needs to be made available. So let's go over that right now. So contract A, let's just call it apples. Because remember, we don't want to confuse ourselves. I'm going to create a variable. I'm going to call it address B. Okay, that's what I need to store. I need to make my contract aware of contracts B's existence. That's the first step, just like in the last time. Then I'm going to say function, and I'm going to set that address. Setting address B, which is I want to set this address B. I'm going to create an argument. What I'm going to do when I call this function, I'm going to pass an address. Underscore address B. This way I don't shadow. Remember? External. Boom. Okay. Now how am I going to set it? Address B equals underscore address B. So that's all it's doing. So whatever I end up passing here, it's going to become this. So now my contract is aware of what address B then is. So see how I'm not using a constructor? See how I'm using a function to set the address that I want to then interact with? This allows me so that I can pass in other addresses where I can then set the address of what address B technically ends up being and use the functions that are available to it. So this is how I can create a really large contract where I can basically set up this contract to see and interact with multiple interfaces. So I want to set the address that I'm first going to want to interact with, which is I want to interact with contract B. Within B, I have the interface of contract B's, and then there's the contract B's and its functions. So now that I set the function, I set the address, I want to actually call upon the B's. So I'm going to say function call hello B's. Okay. I don't need to pass in anything because I'm just calling it. Pure, remember pure, and what was the other one? Pure return. So I'm going to copy this exact thing right here. Pure returns. I have to do it word for word. So string memory. Right? You can't use an interface with pretend arguments. But now I can actually fill in what this means. And what I do know is that it's expecting a string, because I'm saying call hello world bills. So right now, this function has no idea about contract bees or anything. It doesn't know about the interface. It doesn't know about bees. It doesn't know about anything. So I'm going to tell it, well, I'm setting you up for success. I'm telling call hello bees. I'm setting you up so that you can't interface with these things right here. So here's how I do it. So I would go look at that other contract. I would go look at the interface. I would go and look at the functions that are within those other contracts that I can then interface with, and so on and so forth. And what I would do is, now I'm going to say, what was my contract's name? Bees? Yeah, bees. Okay, so I'm going to call bees. Oops, is it capital B? Contract bees? Yeah, bees. So I'm going to call that function. I want to call bees because when I call bees, all things are going to be good. Okay. Bees, I'm going to set it to, I don't know, it doesn't matter what the variable is. I'm just going to say B. And then it's going to equal, let's say contract B, contract bees, which is this interface. Now this interface has the same function body as this contract. So without me even saying it, when I said bees, what it's doing is, because this is inside of my same project directory. This is inside of, this is in here as well. So it's aware, but it is complaining, and it said, what is this? It will in a second. So once I finish this, I'm going to say, I want to set contract bees to address B, which is this right here. Now, when I look here, it says identifier not found. It doesn't know the existence of contract A. Okay. See, when before it was the contracts, the two contracts were in the same file, this contract has no idea. So this is where we now have to do number 2. We have to import contract bees. I want to import this interface so that this interface can pass hello bees, this contract, this function to this interface, which I am trying to connect to, which is called contract bees. So my contract bees is my interface, and I'm trying to use the function called hello bees, which I want to get hello bee from. But it doesn't know what contract bees is. So how do I do that? It's really easy. You just call import at the very top, and I want to do in quotation. I'm going to do dot forward notation. So this is where it can say, okay, just look within this project directory. And if it was in like interfaces, or if it was in contracts, right? This is inside of my contracts files. So I only have to go up once, and it's going to look throughout all of my contracts in my contracts directory, or my contracts folder. See, if contract B was in like interfaces, which I should probably put it there, which I actually will. Let me show you right now. Let me just give you an example. So I'm going to say contract B, contract B's. Oops, I'm going to rename this. This is the contract file I want to interact with. So I'm going, oops, what happened? Okay, contract B dot sol, and end it with an semicolon. It's giving me another error. Type contract Bs is not implicitly convertible to expected type of contract Bs. So why is that? Because I haven't returned anything, so I would have to say return B, which is Bs, and I am going to return what that B is doing. So Bs has hello world, so I'm going to say hello Bs, okay, which is the function that I want to call. And I don't have to pass in anything because it's already passing in the stringed memory. Okay, so when, what is this saying?
I think the problem is we are trying to turn the interface into contract type. So if you turn to the contract type, yeah, if you say Bs instead of contract Bs in the down, in the line that, yeah, if you say Bs there instead of contract Bs, no, not there, yeah, there. Can you say just Bs?
Let's see. So I don't think this is it because it's not aware of what interface that I'm trying to be explicit with. So
is it giving the same error right now? I mean,
let's see. I must have written something wrong and I'm just not catching it. Hold
can
on.
you look at the error right now? Error.
Hi there. I would also like to add on one point over here. Maybe you can change Bs to contract Bs on both the sides. I mean to say in the function, yeah, here where you at line number 22, where, yeah, here contract Bs, and on the right hand side also contract Bs.
Function declared as pure. Is that really the problem? I thought that was it, but is that not true? Okay, that was it. Yeah. Oops. Okay. So I wrote it backwards. Okay. So it needed to, so there was two problems with this. Thank you for catching that. So what I was doing wrong was that I was trying to call the contract when I'm only trying to interface with that contract. That was the first problem. The second problem is that it needs to be like viewable, and it would not be able to be called if I didn't make it viewable. Now the big question is like, how is it able to pass in memory if it's trying to inherit this function as a pure function into a view function? I think the mystic mojo of Solidity is that where I'm incorrect in my understanding is that you can pass like publicly viewable values into pure because it's actually basically the same thing, but you can't go the opposite directions. You can go from pure to view, but you can go from view to pure. Oops. I think that's the answer. Okay. So so now we're actually going to try to interact with these two. So let's do that. So we have both of our contracts established. So one more time, we have an interface called contract Bs. We named it contract Bs. Now let me show you one last thing, because here I imported contract Bs, but let's pretend that I put it into my interfaces because I want to be organized. So I'm going to put contract Bs. Let's put it into interfaces. And when I put it into interfaces, I can see that it is, oops. Did I mess that up? I didn't drag it over correctly. Hold on. Contract Bs. No, there it is. So I have contract Bs. If I go back to contract, A, and I look at this, and I look at this, This should give me an error. It says it can't find it. So usually this is just one additional bump up. It says contract bees is not found. Contract bees.sol. Oh, because it's in the interface folder. So what did I call it? Interfaces, plural? Interfaces, yeah. Interfaces / contract bees. And now I'm not getting a compilation error. So that's how you manage your dependencies inside of your file directory. It's such a nightmare, but once you start understanding and seeing it, that's how you kind of manage it. But once you get that, that's what you're going to start seeing. So when you go to BScan, you're going to see that the import statements are like different, and you're not going to know why. Like some of them are all over the place. You can either choose to copy them or not. It's totally up to you. But this is how you're going to have to manage it. If it's inside of another folder, double dot. If it's inside of the same folder, it's 1. And if it's in literally the same file, you don't have to import anything. Okay, so that's kind of answers the question that you had before, which is about how does it know? Okay, now we're gonna see. So this is these are 2 different contracts technically, and so when I deploy them, I'm gonna basically deploy. I think I'm gonna try to deploy contract B first, and then I'm gonna contract A afterwards. So when I go to deploy, I'm gonna delete these 2. These are my old ones. All right, I'm still connected. Let's see. I'm gonna do. I think the one that I was doing, not apples, right? Let's get rid of that. I'm gonna confuse myself. Let's do. I have contract A and contract B's, right? So it's contract apples, interfaces. So interfaces. This is the one I want to do. So this is contract B and B's. And I have inside of B's, I have B's as well as I have contract B's, which is the interface that I'm using. Okay. So I'm pretty sure what I'm going to do is submit the interface. Okay, this is where I get a little confused personally. I don't think the order matters necessarily. Maybe it does. Correct me if I'm wrong, if you know. But I'm pretty sure I'm going to interface with B's first. So we're gonna do that. So I'm gonna launch the interface first. The interface, which is contract B's. That's cool. And then that's deployed. I'm gonna launch because this was contract B's, so I launched B's, this contract. Now I'm gonna launch the interface, contract B's. I'm gonna deploy that. This may be abstract. It may not implement abstract parent methods completely. It may invoke. Yeah, okay. Let's try that. Doesn't matter. And oh, duh. That's not what I'm doing. I'm launching this contract. This contract already has my interface. And now what I'm going to do is launch contract apples, which is right here. When I deploy that, confirm. Okay, now I have both. So I have B's and I have apples. Okay. So in B's, what I had is hello B's and foo. So with foo, there is nothing there. I can just conduct a transaction. I'm not. When I do hello B's, what should happen is that the function is going to return hello B, which that's true because that's just for this contract in B's. But in contract A, what I need all the functionality of B's here. So the way that I'm going to be able to do that is what I mistakenly did was that I was trying to set the contract that I wanted to interface with, but rather what I'm trying to do is set this up so that the address that I'm going to interact with is this smart contract. So what I'm going to do is set the address of B, which is right here, B's. And then I'm going to copy and paste it in here. And this is setting the address. So this is using this function. This is going to set my variable. Okay. I'm going to set that. So this is if another contract was already deployed. Now I'm going to set the address of my contract. So this is if I wanted to make a contract apples where I can interact with B's. Okay. And what I'm going to try to do is use the hello B's, call hello B's. It's using this function. What it's supposed to do is it's going to use contract B's. So the interface, contract B's, which will use the hello B's function. And hello B's is going to return hello B from contract B's. Contract B's, that's the interface. B, that's the variable that I'm trying to use. And contract B, and use the functions that are available at address B, which is, I've already set that up here. And it's going to return B, the interface of hello B's, which is going to be this, which should be this. I'm hoping to God that this works, because if this doesn't, I'm right though. So hello B. Hello B is now returned. So yeah, I was able to essentially interface with this particular address. How? What I did is that I called on this particular interface because it was available to this contract when it was deployed. This interface includes a function that is hello B's. So what I would do on the block explorer, I would go and look at all the contracts that are available and see, well, where is this hello B's function and what is it going to return and what is it going to do? And then I would go and find it and I'd see, oh, hello B's, this is what it's returning. So if I interface with this contract B's, I'm going to be able to use the functions that are available to hello B in the function body if I call hello B's. So here I am saying, hey, use the interface that I found, contract B's, set the value of B to all the functions that are available to that interface at this contract's address, which is B's. So I just basically I passed in this only. This is the only thing that I passed in. But however, the reason why my contract here is aware of contract B's is because of the import statement. It's aware of the interface. It literally, what it does is that it's not looking at the blockchain for the interface. It's looking at literally my project directory and it's going to interfaces at contract B's. It's looking at this particular function and then it's basically saying, oh, you want to use this interface, but you want to interface, you want to inherit the functions of contract B's. And then once it's basically that's established, how does it know it? Because I set it. When I launched the contract, I set the address to contract B's, which I deployed first. So I was right about that. And then, why? I mean, that makes sense too, because it's a contract that has already been deployed. And all I'm going to do is basically just call back B. Calling back B is calling back contract B's. Contract B's has only one function, which is hello bees. My interface is aware of bees. Bees has hello bees, so it's going to pull hello bee here. And I'm going to return whatever value that's available there. So this could have been any value. So we kind of worked backwards. Without us setting the value, we just returned any value that is already on the blockchain. So somebody could have come here and maybe they could have updated the value of this. When I was showing you updating value, they could have maybe updated hello bees to hello mega bees. And it could have been that. And if somebody else did that, then if I were to return hello bees, it would be a different return statement. So that's like social media, right? Like if somebody else puts a post, then I'm saying, give me the latest post on the chain for this contract. Then it would give me the most recent post. Okay. Okay. So that is that. Man, I really wanted to go through more because I wanted to do one where I could have like made a contract where I'm setting the price of like Ethereum and I want to append it, and then I want to interface with that, which I mean, should I just do it? It's kind of cool. So this is all interacting with smart contracts. I might as well screw it. So let's do this same exact thing. But I'm going to make a contract where all the contract does is that it's going to increase the price of BNB by 100. And in order for us to increase the price of that, what we're going to do is create an interface where we're going to inherit that contract's ability to do so. And we're going to be able to read the value. We're going to be able to set the value. We're going to be able to get the price and everything. But it's already going to be deployed by another contract. And that other contract allows us to do one thing, which is to increment the value. So I'm going to create another contract to interface with that other contract. Let me show you how that works. So that might have sounded confusing, I know. So let me just show you. So I'm going to create a new contract and I'm going to call it BNB price. So this is going back circa to our first example. So I'm going to call it BNB price dot sol. Okay. And I'm going to do pragma and just like before, solidity 0.8.19. And within this contract, it's best to name it the same as your file because I messed up before. BNB price, word for word. So that's the contract's name. Oops, I should probably use square brackets. I mean, yeah, curly brackets. I'm going to set the price of BNB. What was it? $350. So I'm going to do uint public price of BNB. And it's going to equal 350. Now, this is just me setting the price. So the reason why I'm making this is because I want other people to set the price. If I'm wrong, then maybe the cool thing about this example is that an oracle could update the price of the contract of BNB price. And maybe the whole world is looking at this contract for what is the actual BNB price. Now we're going to set up another contract that's going to interface with this contract to always update the price to be what it truly is. Using a smaller example, I'm not going to be using Chainlink to like try to figure out how to update this price, but this is just an example of how like oracles technically work. Okay, so the only function that this is supposed to have is like either the increment or the decrement of this value, or literally the setting of that value. So for now, I'm just going to increment the value. I'm going to say increment, again, external, because this function needs to be called outside of this contract. And curly braces, and I'm going to say the price of BNB, my variable, plus equals means to take the current value and then append it by however much I want, which is, let's say, like $10. Okay. That's it. Now I need to make an interface. So this is my contract. All it does is set the value, and I'm going to want to interface with this function called increment. I want to increment the value by only so much. So I'm going to go to interfaces, and now I want to create an interface for this contract. So I'm going to name this, what do I have here? Interface BNB price. So usually when you create a contract, you'll see a lot of programmers do this, even like when we go back to PancakeSwap and like the verifying of the exchange and everything. You can see that like if somebody made a contract, there's an equivalent like I to it so that people can interface, and this is best practices. So when I am doing it on my end, I'm going to do it no differently, because programmers have a convention, a style. So I'm going to say the same thing. I'm going to say I BNB price, spelt exactly the same. And then in here, what pragma version, I'm going to copy this here. I'm going to close some of these tabs. So these are the two tabs that I want to work with. So in my interface, how do we create an interface? Interface. And it's BNB price. This is my interface, which is the same name as my file. I'm going to just take this license and post it here, because it always asks. I'm going to do the same thing here. Here, boom. Okay, no more licenses problems. Okay, now in my interface, again, we don't make bodies, we just make functions. And I'm going to want a function where I'm going to just want to get the price of BNB where it's at right now. I don't want to have to rewrite that all over the time. So the only thing that I want to interface with is just the price of that particular thing. Okay, so I'm going to basically just get this price of BNB. I'm going to get this interface is going to grab the price of BNB and bring it over. Okay. So how would I do that? Just like before, function price of, and it's already aware because it's in the same project file directory, which it's not actually. I need to tell it that it is. But for now, I'm just going to do this. External returns, and it's going to do a unsigned integer. And that's it. So that's all this is going to do. And then the contract that I want to write, this is going to be what I'm actually using. Okay. So I want to read the price of whatever it gets from this other contract. So say if price of BNB is already deployed and its only function is to increment the value of that price. So I created an interface where I can go and get the price from this contract, sort of like contract B and A thing, but doing it this way. So getting the value. Now I'm going to create a contract where I can read and do all sorts of things to that value. I'm going to use this interface first to fetch the value from this contract, and then I'm going to use this contracts in its functions, and I'll show you how. So I'm going to say read, let's say the price of BNB. And address. The reason why I want to pull an address is because I need to know which address I'm actually interacting with. Remember? I want to interact with this. So this is the contract I'm going to deploy first, or that's already kind of quote unquote deployed. So I'm going to make a function that will allow me to interact with the price of BNB contract. So I need to first establish my value. So it's going to be address public counter contract address, and I'm going to fill in this counter contract address value by making a function that's going to set the counter address, and I'm going to pass in an address, remember? And I'm going to do underscore and just copy this because I'm not going to shadow it. So I'm just going to do that and do external call because I want this to be used by anybody. And then I'm going to set the value of this to whatever the value that is passed in here to set counter address. So I would do counter contract address is equal to underscore counter contract address. Cool. Now that I have set the value of the address that I want to interact with, now I'm going to be able to have more fun. So I want to get the price of BNB, right? So I'm going to do something where I'm doing the exact same thing. So right here, I already say price of BNB. That's the thing I want to do. So I'm going to create a variable called price of BNB in my contract, matching it to the interface. And I know that price of BNB is going to be a few things. It's going to be a uint, probably a 256, as well as it's going to be public. And boom. So uint, oops, sorry, uint. So I'm going to get that value from this contract, from this interface. How? I'm going to get it. So I'm going to create a function. It's called get BNB price. And it's going to be an external call. A lot of externals. And I'm basically going to get the price of BNB. That's what I want. Oops. Price of BNB equals. Now I want to get it equal to the whatever the interface is pulling, which is this. So I'm going to say remember, it's equal to what I want from my interface. So interface of IBNB price, which is going to get the price of BNB from this contract. And how does it know how to do that is because I've already set the address up. And now I want to get that BNB price by counter contract address. I'm passing in the BNB price contract to this, which is telling the IBNB price interface, call this function price of BNB, which is right here, price of BNB. It's equivalent. And then it's going to return that uint, which is the same right here. So which is 350. And then it's going to get the price right here. And then it's going to become the new price of BNB. Within my read, the price of BNB is going to become this value right here, price of BNB. Again, I could have named this anything. I could have named this price of BNB tokens. See, that's the core difference. That's it. It says, oh, then maybe let's make this 256 also. Am I wrong? Type contract IBNB price is not especially convertible to expected type 256. Price of BNB tokens. No. Am I wrong? Oh, I'm not finished. So I'm gonna get that address, which I already have. I already set it, and I'm going to get the price of BNB from here, which is price of BNB. So price of BNB, because now that it's aware, and I'm gonna add my braces there. Now my error went away. So price of BNB tokens is going to equal to whatever the interface is fetching. I am passing here into this parameter, get the price of BNB at whatever counter contract is, and counter contract was set. Contra contract is going into this parameter. It's going to go and fetch the BNB price. How? I'm doing dot notation saying get dot price of BNB. It's going to go here to this contract address and get dot price of BNB. Cool. Right on. So I can also update the value of it as well if I want to. I haven't written this yet, so I can do function update BNB price, and I can call that contracts function and do an external call, and I can say let's say that let's say uint what is this? Price of BNB is going to be equal to 10. So let's just do uint 256 public updated BNB price. Okay. And then what I'm going to say is update BNB price is equal to I believe it would be IBNB price at counter address dot price of BNB, but I want to increment this, so I want to use this increment function. So instead of doing that, I would do increment and call it a day. So it says update. Let's see what this is. Undeclared identifier. Do you mean updated BNB price? Or
You wrote update BNB price instead of updated. Yeah.
Ah, my bad. Increment external. I think it's because update BNB price. Oh, hold on. I'm writing this wrong. What I need to do is if I want to inherit the values and use the value of increment function in my new function, then I need to pass in that this function to my interface. So I'm going to just basically copy this and put it here. And within increment, what I want is to use the increment function. And the increment function is just an external function where all it's going to do is just increase the price of BNB by 10. And that's all it should do. And within this, what I want to do is basically call that function, increment function, using my IBNB price interface. So I think the way to do this would be to call the update function, or the update BNB price. And what I'm going to do is basically set the value of my updated price and set it equal to the price of BNB token. And then by getting the BNB token, it would get it from from there. I don't necessarily even need to do this. I actually can just say update the BNB price. I can actually remove this, and instead of doing it this way, what I can do is just call that function from that interface. So what that would be is, I believe it would be, let me think. I think it would be, let's see. BNB price. And then I think it would be at counter contract address. And from here, I would use increment value and pass in that. And from here, what I'm doing is essentially saying like, use the interface IBNB price, use this increment function, go to this contract address, which is here, use this increment function and update the price of BNB. And then once I update the price, I'm going to get the price and it's going to be plus 10. I was not preparing to write this function, but you know, I think what I just showed you also was that with time and practice, you can start writing Solidity much faster and easier with just in given time and practice. So you just saw that in action. Now I'm going to do this right here. I don't need to import anything because both of these BNB price is right here and IBNB price is down here in my interfaces. Now, what's a little confusing to me is why it's not asking me to import my interface. I'm not going to complain. I'm just going to let it go. Maybe it might not be aware actually here. Yeah. Okay. So it's IBNB price, read the price of BNB. Right. So I'm going to launch BNB price first to the blockchain. So everyone's going to be able to interact with this. I can actually send you guys this contract and you can interface with it on your own. And you could do the same thing with me right now because it's on the blockchain. So I'm just going to deploy this script. And now the price of BNB is 350. If I go here and I press this, it's going to be 350. That's the price of BNB. And if I click increment, it's going to go up to 360. I'm going to change the value on the blockchain. And if I do this again, it's now 360. Okay, so no big deal. I'm going to go to now my interface and I'm going to deploy the read the price of BNB. And since the interface is already inside of this contracts directory, makes my life a whole lot easier. So I'm just going to deploy this contract. And this contract is aware of what IBNB price is. It's in my dependency folder. So I'm going to deploy. It's kind of like my contract A, right? And then if I go here and scroll down, so I can see that I have get BNB price. I have set the counter address. I have update the BNB price and the two variables. So now I'm going to set the counter contract address. I need to get this address from BNB price. So I'm going to copy this one, paste it here. Because if I didn't, I wouldn't be able to get the BNB price. So let me give you an example. So if I look at the counter contract address and try to call this, it's 00000, and I try to get the price of BNB tokens, it's 0. So I'm going to set the address first. I'm going to set the address. Confirm. Now it's set. So this is done, right? If I call this, it's now has been updated. And if I call this, it's also showing up as 0. That's also because I haven't used the function yet. So I need to get the price first in order for this interface to even be aware. This contract is not aware of what the price of BNB tokens is yet, because I haven't called for it yet. So I'm going to use this function, non-payable, get the BNB price. It should be 360. And now if I get the price, it's 360. And I'm going to update the BNB price using this function. Update. Confirm. And now if I get the price, it shouldn't change. It's still 360, right? Because this is only available to this contract. But if I get the price again, confirm, it should be 370 once I get the price. 370. There we go. Okay. So this is like if you were to create a bot, for example, like a trading bot, you would see that there is an existing contract pool, or there is some thing that's out there. Like the pool has $350 in it and you want to interact with it. So you would first like set the contract address to connect to that pool. So you would set the contract to that pool. You would then make sure that you're connected, and then you can fetch the price of the pool. And then you could update the price by adding your tokens to it, maybe. And then by doing that, you can update it, which would send a transaction or a deposit maybe to the price of that pool. And then once you've done that, then you can get the price to make sure that you have actually updated it. It'd probably be better if you can update and get the price at the same exact time, rather than doing it in 2 separate calls like I'm doing it here. So it could be cheaper doing both the getting of this and the updating at the same exact time, where I can do get/update, right? And then just make my parameters 2 parameters where I am getting the price and it's returning me that number, and then I am updating it with a certain number. Maybe I'm the one who wants to update it, right? Because I'm basically using the increment function plus 10, and I'm not actually doing anything. I'm just using this. So I can instead reverse that, and when I update the price, I can be the one who's incrementing it by 10 instead of allowing the function that's in that contract to update it by 10. Okay? And maybe there might be 2 functions within this contract. One can be function increment by 10, right? By 10. And then there could just be a blank one that says function increment in general. So that would be the one where you can assume that's the function that you want to interact with. Because it's not subjected to anything. It would just be the price of BNB. Return me the price of BNB. Okay. So that's I know that was long. So that's basically the full lesson. What I have shown you is how to do a lot of things with smart contracts. I hope that kind of clarifies a lot of different things. All of this is going to be recorded, so you can see step by step, where did we start? We started with Solidity, then we moved into how to interact with contracts within the same file. And then we started interacting with those contracts in 2 separate files where we were using import statements. And then we created an instance where we're using another contract's functions how we would if there was like an already deployed contract or pool or swapping function that you wanted to use that contract, and you created your own interface to interface with that contract's functions. Okay, and you can go and get those functions from the Binance Smart Scan, right? You can go here and you can literally copy and paste the functions that are available in existing contracts and just use those as your interfaces instead of creating new ones. So that way you can create forks or clones or copies of other projects, and then you can interface with those projects in your own unique ways. And that's what this is kind of resembling. And now all of this relates back to Greenfield, because Greenfield is going to have its own essentially set of APIs and interfaces that you're going to interact with. And that's going to elicit a function where you're calling upon the resource mirror. So it's kind of like an interface. So the whole reason why I'm doing this thing, it's like you got to pretend as if the bucket that's inside of Greenfield is being interacted with you, and this is your Greenfield DApp. You're just using an interface to communicate with that bucket, and then you're going to do things to that bucket. Increment function by 10 in Greenfield would be like delete the data, move the data, generate data, create the data, send the data, protect the data, privatize the data. Whatever you want to do with the data is you're going to interface with those permissions. Aha! I hope that makes sense. Let me see if there's anybody even here still. Yeah. So thank you for sticking around. I hope all of that makes sense, why we did this. I know this was long. But if you watch it all the way through in the recording, it should make sense. And what you got to do on your end is basically just do a few things. So here's the summary of everything, right? What you want to do is first try figuring out how to build in Solidity, which is what we initially did here, or I deleted it. So build in Solidity, build in all things Solidity. Do that, and then go and play with testnet and copy and paste those transaction IDs and method IDs and play around with the block explorer and explore that you're going to save this contract, that you know that you're going to be interacting with this contract's functions and transactions, and just kind of get a scope of how blockchain dApps work. If you want to, you can do this example, which is going to be coming out soon with interacting with the BNB smart contracts. And I tell you step by step of what to do if that was confusing, if that part of interacting with testnet is hard. You can do this. And now with actually building contracts and making your own that interface with these existing contracts, that's why we were doing this. So this is the interact with contracts workshop. So you could do it in all three styles that I showed you. Just go back in the video and get a sense of everything. The first one was files in the project directory. The second one was importing from other dependencies within your directory to still do the same exact thing. And then this example was if there was already a deployed contract, whether you're importing things or not, there's already a deployed contract, so you want to use that contract's functions. And how would you do that? And that's what we did today. The same exact thing. So this is everything about how to interact with smart contracts. I also showed you how to import other contracts code into your thing. So you can do the same stuff. Yeah, it's harder because it's more complex code, but you just got to read it and try to understand it as best as you can and try to understand bit by bit of what's going on. Practice the three things that I showed you on your own, and then try to make a function call with an existing contract that's on chain. And that's what our challenge is. So It's not released yet, but there is a challenge on GitHub where you're going to be able to kind of look at the challenge and say for yourself if you can interact with multiple smart contracts to do one particular instance, which is to swap, stake, harvest, send. And that's it. If you can do those 4 things, then you've created your own smart contract that essentially is an automated contract. That's a DAO at that point. Because all you got to do is put in some amount of tokens. It automatically adds it to a liquidity pool like this, stakes it for you, harvests the tokens, whether it's by your command or not. Maybe it could be by a vote, by a DAO vote, a yes or a no value. And then once it harvests, then it automatically sends it to Charity, the contract that I gave it to you there. So this is the full inner workings. Now, that also includes a React tutorial with how to take those deployed contracts and put it inside of a React application. So everything that we did here, then you can actually interact with them on using React. So I'm thinking that that's going to be the next session that I'm going to do. It's either going to be that or ZK-BNB and interacting with ZK-BNB using smart contracts. So that is that. Thank you for being here. Any last questions? Thanks for sticking around for the lecture. It was great. No? All right. Thank you. Much love. Much respect. Have a good rest of your week. I hope that helped. Keep coding. Keep trying new things. Keep building towards whatever you're building for. I know you can do it. Make it cool. Make it unique. Think outside of the box. And I'll see you here next week. All right, guys. Peace out. Take it easy. Goodbye.